Hi, good afternoon. This is Mr. Cassidy, and I'm doing a review of our concepts in Chapter 1. We're starting with Lesson 1, which is rational number conversions. So let's review. First, what is a rational number? Well, a rational number comes from the root word ratio. What we mean is that any number that can be turned into a ratio is rational. And ratios are just the same as fractions. So any number that can be turned into a fraction, say 2/3, that would be a rational number because it can be a fraction. All percents are rational numbers. So let's look at 75%. Well, that could be converted to a decimal, 0.75, which can be converted into a fraction, 75 over 100, which is the same as 3 over 4. So therefore, 75% is a rational number. But some of you may be wondering, what about repeating decimals, those decimals that repeat? So here we have 0.7 repeating. Yes, even repeating numbers, repeating decimals can be turned into a fraction. How we do that, there's a little trick. The repeating number can just be divided by, well, if this is the tens place, we're going to take 1 away from 10. So instead of writing 7 over 10, we write 7 over 9. And that would be a fraction. So 7/9 is a rational number. So, long and short of it is, rational numbers is anything that can be turned into a fraction. Any number that can be turned into a fraction. So the primary operations we're doing are turning a fraction into a decimal. So let's review how to do that. Let's say I've got a number like, 3/8. Let's make it a tiny bit more complex. Let's say it's 2 3/8, and I want to convert it into a decimal. To do that, I'm going to use long division. Now, 2 is my whole number, so I don't really need to worry about that because the whole number 2 is just going to be the number 2 before the decimal point. So what I do need to do is long division with 3/8. A trick I learned was this. I draw a field goal here around the top number, and since that's the number inside the box, it's going to get put inside the box for long division. But 8 can't go into 3, and so this is where I'm going to have to add a decimal point and use long division to actually get the decimal. That's the equivalent of 3/8. So first, 8 doesn't go into 3, so I put a 0 and add my decimal point here. Now I can add a 0 here, and after the decimal point I can do 8 going into 30. So how many times does 8 go into 30? Well, it goes in, let's see here, one of the multiples of 8 is 24. That's 8 times 3. So I'm going to go ahead and put a 3 here. 3 times 8 is 24. And I subtract it. I'm going to get 6. 30 minus 24 is 6. Great. 8 can't go into 6, so I know I'm on to my next digit. I'm going to add a 0 here and carry it down. Great. 8 goes into 60. 8 goes into 60 7 times. And 7 times 8 is 56. 7 times 8 is 56. Subtract, and I get 4 down here. Great. I'm going to add one final digit. 8 can go into 40. 8 goes into 45 times. This is a terminating decimal because 5 times 8 is 40, and there are no remainders, so the decimal is ended. 8 can't go into 0 anytime, so the decimal ends, and it's a terminating decimal. So my final answer, since I had 2 and 3/8, my final answer is going to be 2.375. Great. Well, carrying on. Another common problem we're going to have to do is we need to convert our decimals into fractions. So, converting a decimal to a fraction. How we do that is just by using the place value. Use the place value to create the fraction. So, for example, I've got a decimal here. Let's say 0.21. I know 2 is in the tenths place. 1 is in the hundredths. And I'm just going to go to that last decimal place. In this case, 1 is the last decimal place here for this decimal. And since 1 is in the hundredths place, I make 100 my denominator and 21 my numerator, because this is 21 hundredths. And that's how I make my decimal into a fraction. If possible, I would simplify, but in this case, I don't think 21 and 100 can be divided by any of the same things, so I'm going to leave my answer as it is. What if it's repeating? Well, if I have a repeating decimal, 0.42 repeating, in this case it would be in the hundredths place, but I'm going to take away 1 and say 42 out of 99. Now, this trick only works if the repeating digits are right after the decimal place. I'm aware of that. But for our purposes, this will work with most of the problems we're looking at. And at the end of the day, what I would be most concerned about is, can you convert this into a decimal? And you would use long division to convert it, and you would find that 42 repeats forever. And can you convert a regular decimal into a fraction like this? In this case, 42/99 could be simplified. We could divide the top and the bottom by 3. And we would get, let's see here, 14 as my numerator and 33 as my denominator, 14/33. So our last step would be, maybe we get a fraction like 14/33 that's repeating. How do we turn that into a decimal? Let me go ahead and flip over my paper here. All right, I'm going to convert a repeating decimal, or repeating fraction. Sorry, I'm going to convert a fraction to a decimal. In this case, I know this is going to be repeating because the denominator is 9, and that's 1 less than 10. And for some reason, anything that's divided by 9 or 99 becomes a repeating decimal. So in this case, again, draw my field goal and put 1 inside the division and use long division. So in this case, 9 can't go into 1, so I'm going to go ahead and add a decimal and a 0, so that 9 can go into 10. Well, how many times does 9 go into 10? 1 time. 1 times 9 is 9. When I subtract, I get 1 remaining, and so now I'm back to a 10. This is going to keep repeating, because every time 9 will go into 10 just 1 more time, and always have 1 more as the remainder. Once I see that I've got a repeating decimal, I can answer the question by just putting a bar above the repeating digit or digits. In this case, it's 0.1 repeating. All right, we've been looking at rational numbers. All the numbers we've covered have been rational. We've converted fractions to decimals and decimals back into fractions. And we've also looked at some of the tricky repeating ones that are also rational numbers. Thanks. I hope this has been informative and a good review.